Okay, so as I said in the previous video, there are two approaches to take for solving exponential equations. I've shown you the one here on the left where we try to write both sides of the equation as powers with the same base. The other approach, and the approach that will work every single time you try it, okay, is to use logarithms to isolate the variable. In order to do this, we need to have isolated the exponential term. So I'm going to write that first. Isolate the power, that exponential term, that power that has the variable in the exponential level. Now this problem is already set up that way. Now what are logarithms? Logarithms are the inverse operation of exponents. So if I want to remove this variable from the exponential level, I can take the log of both sides. Now, what logarithm I choose is up to me. I can choose the natural log to take the both sides. I can take the common log. I can do log base 2. I could do log base 16. It doesn't matter, and this is important because the calculators that we're using right now. Okay, can you do common log? Yes. Can we do natural log? Yes. In this case, what makes the most sense is to take a logarithm with the base that is the same as the base of the exponent. Because what's that going to give me? So if I start with this, if I take log base 2 of both sides, okay, so in this case, I've got log base 2 of 2 to the x equal to log base 2 of 16. What happens to this x? Here comes the eraser. The x moves in front. When we have a logarithm with an exponent within it, we can move that exponent in front. This is the fact of a logarithm undoing the exponent, moving it down to that first level of the problem. Now, what is log base 2 of 2? Okay, that's 1. This is why using log base 2 makes sense, because if I use the logarithm with this as its base, that logarithmic term is going to turn into 1, leaving me with just x equals log base 2 of 16. And you can use a calculator at this point to plug this in. You're going to get 4, which is exactly the same answer as before.